We will start now. Srinu, Bala, Baji, can I start now? Naveen.
Yes.
Okay. They will join slowly. They are thinking still 6:30. 6:30 we have class. They are thinking like that. They are joining. Okay. Anyway, we will continue. Huh?
Okay.
Yeah. Okay. We will start it. Huh? See, today we are going to discuss about architecture. Architecture. For any database, architecture is common, right? Maybe flow will change. Flow will change in the back end. But architecture is mandatory. Mandatory. See, what is architecture? While executing query, after some time you will get the result set, right? Result set or output. But in back end, there is a huge process to complete the request. So from starting point of the query execution to until get the result set or until query execution completed, internal or back end flow, we call it as a architecture. See, normally we are going to execute any query. From starting point of the query, let's suppose you are running a one select query, select star from EMP. Okay, let's assume you are running select star from EMP. You will get the result set, either 5 records or 10 records. As a like user, end user, you are like you are able to see you are running the query, you are getting the result set. That's it. But in backend, there is a huge process is there. That backend flow or process, we call it as a architecture. From starting point of query execution to until get the result set, backend there is a huge process is there. That process we call it as a architecture. This architecture is, each database has its own architecture. That backend flow will be changed from database to database. Oracle has its own architecture, MS SQL has its own architecture, DB2 has its own architecture. In the same manner, PostgreSQL has its own architecture. Okay. Maybe flow will change, but architecture is mandatory. As a DBA, you should be aware of end-to-end back-end process of your database. Then only you can able to estimate where exactly what is happening. Let's suppose one user has given complaint. We are facing slowness, or else we are getting so and so permission error. In that case, as a DBA, you have to understand the back-end process. What exactly happening, which step, what is happening, that things you should be aware. Then only you can able to provide the solution for that issue. If you are not sure about the architecture of that specific database, you are not a DBA. You are not a good DBA. You are unable to provide the answer to that solution. Okay. To provide the solution for that issue, definitely you should be aware of end to end of that back end flow. That back end flow, we call it as a architecture. Okay. See, this architecture is common for Architecture is common for all databases. Coming to PostgreSQL, we have 3 levels of architecture. One is general architecture, the second one is memory based architecture, third one is process based architecture. Okay, there are 3 levels of architecture in PostgreSQL. First one, see, you just remember this pointer. PostgreSQL purely operating system based architecture. Purely operating system based architecture. If you are doing performing any activity on top of database, the query details will be appears on top of operating system. See, whatever the work you are doing at database level, after logging into the database, that query or that request details will be appeared on top of operating system. That is the reason we call it as a PostgreSQL purely operating system based architecture. Please remember this point, PostgreSQL purely operating system based architecture.
So it will carry OS to OS, the architecture, or same?
See, internal linking, whatever the queries you are running on top of database level, that will be appears on top of PostgreSQL. This one, operating system. For each process, each request, one process will be created on top of operating system. I'll explain you. Give me 5 minutes, huh? You will get all the clarification.
Okay.
See, first one, general architecture. General architecture. This is common for all databases. Okay, but terminology might be changed. In some areas. Remaining everything is same. It means from starting point of query execution to until get the result set, the backend process or flow, we call it as a general architecture. See, architecture and general architecture both are same. For architecture also same thing I told. For general architecture also I'm saying same thing, right? So general architecture and architecture both are same. See, coming to PostgreSQL flow. Coming to PostgreSQL flow will be like this. Like below. See, normally end user will execute the queries, right? End user only will access the database. He will run the queries. He will do the operations. So starting point is either end user or DBA or developer to run query from any of the source place or client place, right? See, hit the database. Client place is mandatory, right? We call it as a client or source place, right? Execute the query. Mandatory. From client only, client interface only, we will run the queries, right? Queries. So actually we have 3 options to access database. End user can access the database administrator can access the database, developer can access the database. Any of these 3 can access the database, right? So let's assume either end user or DB or developer should run a query. You want to run a select star from EMP query, okay? From any of the source place or client interface. Coming to PostgreSQL, see, in PostgreSQL, we have 3 types of clients. To access database, we have 3 client interfaces. One is GUI, graphical user interface. Okay, it is a GUI tool to access the PostgreSQL database. That is pgadmin 2. There is a tool called pgadmin tool. That is later upgraded to pgadmin 3. Later it is upgraded to pgadmin 4. Now it is named it as a pgadmin 4. Okay, there is a graphical tool. And one more tool, Pentaho. It is also one graphical tool to access the database. One more tool, DBweaver. This is also one graphical tool. DBZolo. These are the 4 tools we have to access PostgreSQL database. See, I'll show you. pgadmin 4. This is the graphical tool to access database. Okay. In addition to this, we have Pentaho, DBZolo, DBweaver to run the queries. So that is the GUI option. Second one, CLI, command level interface. We have only one utility, PSQL. That is the command level utility to access our PostgreSQL database. Third option, I think you all people are aware of this one, app servers. Always we will listen this project, right? App servers and web servers. App servers means Apache Tomcat servers or else JBoss servers, SPS, Solaris servers. They will use to access database, right? They will use to access our database. So how they will access database from app servers, web servers? Normally they will create a connection string. I think you people heard this point. They will create a connection string in their application server, right? See, what is connection string? Connection string is a file. It will contains database connectivity information in one text file, like below. See, the text file will contains information like host name is equal to database server IP address, database name, username, which user is using to access database, port number, which is trying to access. This information that file will contain. See, this is the information like this: host, username, database name, port name. They will call that file to Tomcat or JBoss server configuration file. Normally we call it as a connection string. So now we have three options to access database, right? End user or DBA or developer, either GUI or CLI or app server. He will raise request. See, here request means in database terminology, running query, we call it as a raising request. Okay, let's suppose you are running select star from EMP. That means you are raising a request in database terminology. Let's assume any of these three places user executed one query, either GUI or CLI or app server, user executed one query. Okay, see, once query executed from any of the above place, either GUI or CLI or app server place. Okay, first this query will reach us to PostgreSQL server operating system. See, that is the reason I told PostgreSQL purely operating system based architecture. Once end user or developer executed the query, it will reach us to operating system where PostgreSQL server is running. Okay, it will reach us the operating system. In PostgreSQL server operating system, there is a process called postmaster process. Please remember this. In PostgreSQL operating system, there is a process called postmaster process. It will takes the request from end user or DBA or developer who runs the query. From him, it will take the request. Okay, request means what is the query he is running, it will get that request. You got my point? On top of operating system, there is a process called postmaster process. It will take the request from end user or DBA or developer. See, process. What is process actually? In Linux, any worker to perform task, we call that worker as a process. Here I told postmaster, right? Postmaster also one type of worker to perform the work. So here process means in Linux, any worker to perform task, we call that worker as a process. For each process, one specific ID will be there. We call it as a process ID or PID in Linux server. Okay. See, then directly I'll do one thing. Process. What is process? Okay. That is once query executed from any of the above client place, GUI or CLI app server place, first this query will reach us to PostgreSQL server operating system. In PostgreSQL server operating system, there is a process called postmaster process. It will take the request from end user or DB or developer. Okay. Then directly postmaster will perform host based authentication. Earlier we discussed about security, right? This is the high level security mechanism. PostgreSQL will achieve PostgreSQL will achieve security using host-based authentication. Okay, host-based authentication. What is host-based authentication? Remember this point. First one is postmaster process. Okay? Second one is host-based authentication. You have to remember these things. What is host-based authentication? Whether user connecting from authorized IP address or not. Whether user is authorized to access specific database or not. Okay. In PostgreSQL, we have a configuration file called pg_hba.conf file. Please remember this point. pg_hba.conf file. In this file, all the trusted and authorized user or database or their IP addresses will be located. Based on this file, postmaster will perform host-based authentication. See, small thing, Baji, Bada. Here, host-based authentication means always PostgreSQL server will runs on separate IP, right? To access the server IP, you have to connect from your client machine. That means your IP address is different, database server's IP address is different. To access the database server IP, first your username, your IP address should be treated as a trusted in the database server. Then only you are the authorized user. Okay? Or else database will not allow connection from any user. Let's suppose, see, I'll tell you one example. PostgreSQL server running on 192.168.12.13. Okay. Here, Baji trying to run query from his personal machine. Okay. Personal machine. The IP address is 127.0.0.1. Okay. He is trying to access database using username Baji. Okay. Username Baji is you want to connect to test database from his local machine. Okay. So for that PostgreSQL server, Baji user and Baji IP address and Baji database should be defined as a trusted. Then only Baji can run the query. Okay. Or else otherwise PostgreSQL server blindly rejects the connection. Okay. This way they define the security. If the IP address or username or database not authorized, blindly PostgreSQL server will reject the connection. We call this as a host-based authentication. Anyone have doubt on host-based authentication? Practically, I will show you. Okay.
How will we authenticate this server? We need to specify the IP.
Wait. That is the reason I told you already. See, in PostgreSQL, we have a configuration file called in PostgreSQL, we have a configuration file called pg_hba.conf file. In this file, all the trusted and authorized user and database and their IP address will be located. Okay. Based on this file, postmaster will perform host-based authentication. I'll tell you how to add the new IP address, how to add the username. I'll tell you later. Okay. Give me
So
five.
if new user is came, then we should need to add the IP address and everything in that file.
Correct. I'll show you practically. Okay.
Yeah. For example, if we want to add around about 10,000 users, then also we should need to add all the IPs and usernames to the file.
I'll tell you. Okay. That is a different concept. We have a big concept for that. Okay. I'll show you. Okay. I'll tell you. Okay. For now, this is architecture, right? So you just think about what is host-based authentication. Okay. So first postmaster will perform host-based authentication, right? Once get the request, it will perform the host-based authentication. How it will perform host-based authentication? Based on the pg_hba.conf file, it will perform the host-based authentication. Okay. See, now, once if user authorized, see, let's assume a user is authorized, that Baji username details and IP address details are located in pg_hba.conf file. So Baji is a trusted user. So see, once if user authorized means postmaster process will create a one process ID for that request. See, until host-based authentication done, there will be nothing. Once host-based authentication done, then only postmaster process will create say one separate, see, one separate process ID for that request, that Baji request. Okay, Baji request. Baji running one query, right? See, query, let's assume select star from EMP. Okay, Baji running this query. So for this complete request, we call this as a complete request. This IP address details, database details, user details, query details, all will be there. We call this set as a request. So once user is authorized means postmaster process will create say one separate process ID for that Baji request. Then it will means then that process ID will assigns to PostgreSQL server process. Now this is the second process. Earlier postmaster process, right? Postmaster just take the request from end user. It will performs the host-based authentication. If user is authorized, it will create a one process ID and it will assign that process ID to PostgreSQL server process. One is postmaster process, another one is PostgreSQL server process. By seeing process ID, PostgreSQL server process will come to know all the details of the request. See, I told you, right? All these details one process ID will create. So by seeing the process ID, it will come to know easily. Okay, so and so IP address, so and so user. Sorry.
It will create a dedicated process ID for every request.
Correct. Every request there is a dedicated PostgreSQL process ID. Okay. For every request, if you are running one query means if you are authorized user, for dedicated one PostgreSQL process will be created. I'll show you. Okay, how it will create. See, by seeing the process ID, PostgreSQL server will come to know that okay, this process ID belongs to Baji, user Baji. He is running select query. He is running from so and so IP address. It is just like a this one. Let's suppose if you go to hospital, okay, hospital. Let's assume you go to ENT hospital. Your problem is headache. Okay, headache. First, what is there? Receptionist will be there, right? Receptionist. She will collect all the details. See, if your problem related to ear, nose, throat, then only you are authorized. Why? You came to ENT hospital. If your problem is headache, you are not authorized, right? This hospital is not suitable for you. Let's assume you are suitable. Your problem is nose problem, something like that. So once you are authorized means authorized. That means your problem is related to that same hospital. Then what receptionist will do? Receptionist will give you OP number, right? OP number. That means queue. You have to wait. In that file, she will write everything. Your name, your address, your problem, she will write, right? So she will give you one file. For that file, one number will be there. Then what she will do? She will transfer file to doctor, right? Doctor. By seeing the file or OP number, doctor will come to know all the details, right? Then he will start treatment. You got my point, huh? In the same manner, postmaster is a postmaster just like a receptionist. PostgreSQL server just like a doctor. So complete responsibility depends upon who? Doctor only, right? PostgreSQL server process only. Postmaster is just dummy. It is like a supervisor process. Got my point, huh? Postmaster only useful for host-based authentication and to create a process ID. That's it. Remaining work and everything will be responsibility of PostgreSQL server process. See, now PostgreSQL server process will perform generic steps. Once it gets the PID from Postmaster, it will perform the generic steps. These steps common for all databases. Generic steps, we call it as a elastic steps. This is common for all the databases. Elastic steps. Okay. See, first one, syntax. Whether user running query having proper syntax or not. Okay. Syntax or not. First, it will not bother about access right and all blah blah blah. It will not bother about anything. Just it will bother about syntax. Whether user running proper syntax or not. If syntax wrong means it will throw syntactical error. Even though user doesn't have access on specific table or object. First preference will be syntax only. If you have any doubt, you can try this. Let's assume you are going to run select star from EMP. Let's assume you don't have access on employee table. Still, you can try with the wrong syntax. Select EMP something something. Then it will throw a syntax error. It will not throw a access related error. Okay. First, it will bother about syntax error, syntactical error. Second one, security. Whether user has proper access on specific table or object. Once your syntax is correct, it will check whether user Baji has select access on employee table or not. Okay. Whether user Baji has insert access on table or not. Like that. It will check the access later. See, first host based authentication is the one level of security. Second one, object level security. Okay. There are two levels of securities are there. We will discuss in deep later. Okay. Next step is resolver. If user running that query first time or second time, it will check that. See, suppose Baji running select star from EMP. It will check, resolver will check whether Baji executed same query already or not. Okay, in buffer cache. All the times already existed query result set will be located in a buffer. This is common for all databases. Already executed queries will be stored in a buffer for any database. PostgreSQL server process first checks in buffer whether same query executed earlier or not. If it found same query, it will get the result set from buffer itself. Displayed result set to end user. No need to go to disk to perform request or task. Okay, so there will be huge resource save. There will be no IO headache. I'll tell you. See, normally end user will be there. He will raise a request. Buffer is there. Disk is there. Okay, disk is there. Normally, for the first time running query, data should be fetched from disk. For the second time running query, data will be available in buffer. So no need to go to disk to get the data. We can get data from buffers. So there will be less IO consumption, less time consumption if you get data from buffer. Okay. If you want to get the data from disk, means it will be time consuming, it will be IO overhead on the operating system. So always second time running queries will be faster than first time running queries will be first time running queries. So always resolver will check whether this query already executed or this is the first time. If it is already executed, it will get the result from buffer. If it is the first time, see, always second time running queries faster than the first time running queries, until unless you have not cleared the buffer cache. If you clear the buffer cache, means always it will be treated as a first time running query only. If you are not clear the buffer cache, it will treat as a second time running query. Directly it will get the result set from buffer cache. See, default cache entries will be cleared after certain limit. Okay. Select from EMP, first time running. 100 queries executed, 100 queries. See, first time you executed one query. Let's assume your buffer cache limit is 100 queries. At a time, it can able to store 100 queries. Okay. If 101 query comes, first query will be removed. Okay. Will be cleared from cache. Cleared from cache. First in, first out method. FIFO method. Okay. So here see, let's suppose you executed select from EMP first time. Okay. After that you have executed 100 queries. Now 101, see, same query you are running as a 101 query. Then again it is treated as a first time. If you executed this as a 99, so it's treated as a second time query. So cache limit 100 entries, 101 will be treated as a new query. So during the performance tests, we will clear the cache. Okay. Why? If you want to know exact metrics of the query execution time, always we have to clear the cache. Then only you will get the exact time metrics. Or else second time it will be gives the less time. You cannot decide, okay, this query completing faster. You should not decide like that. If you want to get the exact time of exact execution time, you have to clear the cache. Then you have to run the query. Okay. See, if query comes first time means there will be huge process. While allocating memory and IO and required resources, there is a huge process. So fourth, if it is a first time request, it will goes to optimizer. Optimizer will generate best least cost execution plan for the request. See, least cost execution plan. Then it will assign that plan to next step. What is best least cost execution plan? See, best least cost execution plan. You have to go to Amirpet from High-Tech City. Okay. There are number of ways. But you have to choose less distance, less price, less time. We call it as a best least cost execution plan. Okay. Plan. Even though you have number of plans, optimizer will choose best least cost execution plan. It will assign that plan to dispatcher. Dispatcher, what it will do, it will get the plan from optimizer, follows as it is on top of disk. It will get the result set, displays to end user. Okay. End user or DB or developer, see. Now end user get the result set. This one optimizer, just like an engineer dispatcher just like a labor. Okay, labor. What optimizer told, dispatcher will follow same thing blindly. What engineer told, labor will do same thing, right? In the same manner, what optimizer told, dispatcher will follow same thing, and end of the day, it will give the result set to end user. So this is the general architecture. I'll cover it briefly. See, first end user or DB or developer will raise the request. From where he will raise the request? Source request, either to GUI or CLI or app servers. Once he raised the request will reach us to operating system. Request reaches to operating system. What operating on top of operating system? There is a process called postmaster process. It will performs. What it will perform? Performs host-based authentication. Okay. Once user authorized, it will create the process ID and assigns process ID to PostgreSQL Server process. It will perform generic steps. You will get the results. This is the general architecture, complete brief overview. Anyone have any doubts on top of this general architecture? Hello?
Babu, is there any default port also?
Port,
Yeah.
Yes. 5432 is the default port. We will discuss later. During the installation, I will tell you, okay? 5432 is the default port for Postgres, okay?
Can you show the graphically? Then it will be easy to understand.
No. This is general architecture for all the databases. Our
Okay.
PostgreSQL one, we have, I'll show you the diagram. We have still,
Okay.
right? Memory-based architecture and process-based. Once this two done, I'll show you graphical representation.
Okay.
Okay. Any questions? This is common for all databases. Common flow. General architecture means. Aji, Bala, any doubts? Yogesh?
Yeah, Ramgar, do we have like a client as well, like Oracle client we have on TNS same thing?
That's what I told you, right? That's what I told you. Client means that is a source place to execute the queries. We have three types of clients. One is GUI, one is CLI, one is app server. GUI means we are using pgadmin 4 as a GUI client. See, pgadmin 4 tool to access database. If you don't want GUI, you have another client called CLI, command level interface. That is a PSQL. PSQL is the command level interface to access database. You have one more option, app servers. Either app servers, Apache Tomcat server, JBoss server also you can use to access database.
Right. I mean, I'm asking like we have Oracle client software, right? Apart from like SQL developer and all, we have something that like TNS.
PSQL, right?
Actually, he's asking. We have Oracle client and SQL client. Like we need to install from in the client mission to connect.
Yes. We have. That's what I told you, right? PSQL is the client interface.
Okay.
So that is like
by default it will comes. Okay, it will comes with installation.
right. That comes with the server itself, right? But is SQL can be installed just alone, standalone?
Alone we cannot. It is bundle. Okay, it is bundle. I'll show you. No problem.
Okay.
No, the question is different from Babu. So, for example, if you need to connect any server, any database, we have to choose the network authentication like host number, port number, which database we are connecting.
Correct.
Through that, PSQL is a host-based SQL command prompt, right?
Yes.
So prompt we can administrate the database. So you want
No. PSQL is a command level interface to access the database. You cannot perform any server level things. Only to execute the queries. Just like a Oracle.
Serverless things means I need to connect the database, Postgres database, for example, test database. I used to connect PSQL username and password at the right so database details, right?
Correct.
So it will connect to the database.
Correct.
So those information, where can I place that?
Which one?
These kind of information, where can I place that?
Yes, yes, you have to wait for that only. I will tell you connection information. How to access remote connections, okay?
Yeah,
Remote
this is the
database.
question we asked that.
Yes, how to access remote database using PSQL, I will tell you, okay? PSQL. From any mission you can access remote database. I'll tell you the details, sir. During the database connectivity session, I'll tell you. Okay? So,
In architecture, you do not pay the memory component like buffer cache.
No. That is the reason I told you, right? See, we have 3 levels of architecture here. See here, 1 second. We have 3 levels of architecture. One is general architecture. This is common for all databases. Still, we have memory-based architecture and process-based architecture. Just now, I have covered only general architecture. Okay, this is a general flow, generic flow. I covered. I have to cover remaining things. Okay. Yeah. Any questions on general architecture? Okay. So fine. I'll proceed with memory-based architecture. Before proceeding, if anyone wants break, just take a 5 minutes break. No need to disconnect. You just go for 5 minutes break. Just come back. In the meanwhile, I'll have breakfast. Okay. 5 minutes enough. Thank you.
Okay.
Yeah.
So now we are going to discuss about memory-based architecture. See, earlier I told, right, already. Sorry. As it is purely operating system based architecture. For any operating system, process the request, RAM is the heart, right? Especially PostgreSQL purely working based on RAM only. Memory allocation will be happens like below in PostgreSQL. See, shared buffers. First thing is there is a parameter called shared buffers. Here we have 2 types of memories. So memory allocations. Local area memory allocation. Local and global. Global area memory allocation. Okay. There are 2 types of memory allocations. Okay. We cannot not global, sorry, shared memory allocation. We call it as a local or backend area memory allocation. 2 types of memory allocations. First, I'll discuss about this one, shared memory allocation. See, there is a parameter called shared underscore buffers. First part, there is a parameter called shared underscore buffers. In any operating system, if you have a 4 GB or 8 GB RAM, if you install any software, in addition to that software, another default process will be running, like root user, kernel user, LDAP accounts. Right? See, if you get any operating system, let's assume 8 GB RAM is there, by default 2 GB or 3 GB already utilized, right? With the default process. In the same manner, if you want to install any software, in addition to that software, already some additional processes will be up and running in that server. So, see here, other users consuming more RAM. Our intention is this server for our database, but all other users are using RAM. See, original intention is that it's a complete server for your purpose, your PostgreSQL purpose. You took that server for your complete purpose. Later, after taking that server, you came to know that In addition to PostgreSQL, other root user LDAP accounts are using RAM. So see here, sometimes root user and kernel users itself consuming 90% of the RAM. But by the end of the day, all other users, other processes, owners blaming PostgreSQL. PostgreSQL only completely consuming the resources. They're saying like that. The actual fact is all other users consuming, they are blaming PostgreSQL user. So PostgreSQL people decided don't go with the resource sharing with other users. They decided to go separately. So for that, we have a parameter called shared underscore buffer. See, we have a parameter called shared underscore buffer in our PostgreSQL.conf file. I told you already, pg underscore hba.conf file to manage the host based authentication. There is a one more file called PostgreSQL.conf file. Anyone is there from Oracle? Oracle P file is there, right? P file and SP file. Sorry. See, someone keep it mute, Setaram. Put in mute. Okay. See, in PostgreSQL server, we have a configuration file called PostgreSQL.conf file. It's just like a SP file in Oracle. This means we will assign piece of RAM dedicatedly for PostgreSQL operations. That dedicated RAM, we call it as a shared underscore buffers. We will never allow other users to this dedicated RAM. Also, we will never use RAM other than our shared buffers limit. Got my point? Only for PostgreSQL operations dedicatedly we can allocate some piece of RAM from total RAM. We call that dedicated RAM as a shared underscore buffers. Okay. If you assign some value for shared buffers, either 1 GB or 2 GB, you can, as a PostgreSQL user, you never cross that limit. At the same time, you will never allow other users to consume your RAM. That is purely dedicated for PostgreSQL operations only. Maximum limit is 25% of the RAM, total RAM. Total RAM we can allocate as a shared underscore buffers. Sometimes if you are sure no one is using remaining RAM, in that case, you can assign 35% of RAM as a shared buffers. If you assign 35% without having clear-cut idea on RAM usage, the server might crash. See, let's assume our system RAM is 16 GB. You want to assign shared buffers 25%, right? That means 4 GB as a shared buffers. PostgreSQL server never cross the 4 GB limit for PostgreSQL operations. Even though it don't have enough memory to process request, it will throw a out of memory error. Out of memory error, okay? Suppose if other processes utilized more than 75% RAM, PostgreSQL no usage at that time. Still, it will not allow other users to access our dedicated memory. If you change this parameter, you need to restart the PostgreSQL services. This memory is complete PostgreSQL server level. This memory will be useful for PostgreSQL operations. Okay. See, if it is a bigger value, your performance will be very faster. Will be faster. But while assigning this parameter, need to consider remaining users uses on this server. Okay. If no one is using, we can assign 5% of total RAM as a shared underscore buffers. Without knowing usage information, if you assign 35%, there might be chances for server crash. Okay, server crash. That is the reason don't go with the 35%. It is for PostgreSQL operations and data standing, data catching. That information only this PostgreSQL shared buffers will be useful. Okay. Next one, work underscore mem. There is a parameter called work underscore mem.
Rambu,
Yeah.
do we have any thumb rule to set these values?
Yes, I'll tell you. All the parameters, I'll give you one link. Based on that, it will give you a complete template. Okay. Which parameter, how much value you need to set, it will give you template.
So you
And if
generally need to
we
calculate.
can't do the memory size, then how much it will take as default?
Default, yes, exactly. Super question. Shared buffers default value is very less. That is 128 MB. Okay, very less.
Okay, okay.
128 MB. Never proceed with default value. Okay.
Okay.
Your performance completely gone. If you are proceeding with 128 MB, performance completely gone.
Is there any way to calculate these values based on the memory RAM?
Yes, that's what I told you, right? If your system RAM is 16 GB, 25% you can assign as a shared buffers. 25%. Okay, sometimes if you are sure no one is using the system, then you can assign 35% as well. If you are sure, if you are 100% sure, then only you can assign 35%. Okay, yeah. So now work underscore mem. In PostgreSQL, if any query or operation performing either hashing or sorting operations, this work underscore mem will be useful. Work underscore mem will be consumed. This is a local memory. That means from the remaining RAM, it will consume. Okay, not from shared buffers. From the remaining RAM is there, right? After assigning the 25%, remaining is there. From the remaining RAM, it will consume. See, once the work done, once work completed, this will be released automatically. Okay, automatically. Default value is 4 MB. Always this value should be either 4 MB or 8 MB. Okay. Worst case 16 MB. If you keep it bigger value, huge number of chances for out of memory area. Okay, out of memory error. See, this will be useful only when sorting or hashing operation. Anyone have idea when hashing and sorting operations will be performed for each and every query? Hashing will be performed. So it is required for all queries. But right, hashing mandate, right? Either select, insert, delete, update, whatever it is. It is hashing mandatory. Any confusion? Hashing, see, to get the record from the specific location, hashing algorithm will generate the memory location of that record, right? So either insert or delete, update, whatever it is, first it should get the memory location. For memory location generation, hashing algorithm will be generated inside. So hashing generated means definitely it will require work underscore mem. So for any query, work underscore mem is a mandatory. It is a local area. The default value is 4 MB, but see, one employee table is there. In the employee table, employee number and employee name is there. Select star from employee. Result set will be either ascending or descending order. Default either ascending or descending order will come, right? That means by default sorting operation is there. See here, if you are doing insert, delete, update operation, insert into EMP values. See, hashing algorithm will be generated for value 7. It will get memory location, right? memory location for record 7. 7 records will be stored in some memory location. For that, hashing algorithm will be generated. So at any cost, hashing algorithm and sorting is mandatory. See, for each and every PostgreSQL request, work underscore mem is mandatory. This is a process based value, not like a server level. Okay, not like a server level. If you assign 2 MB as a work underscore mem, 10 processes connected at a time, all the 10 processes will utilize 2 MB each, total 20 MB from, this is wrong, total remaining memory. Okay, got my point? So while assigning work underscore mem value, be careful, consider maximum connection limit as well. If your maximum connection limit is 1000, think about worst case and assign work underscore mem value. Okay, always work underscore mem into max connections value should be less than the total RAM. See, total remaining RAM. Got my point? Total RAM, assume 16 GB, shared buffers 4 GB, max connections 200. Now how much? See, remaining, what? How much remaining? Remaining 12 GB RAM. So always max underscore max connections star work underscore mem less than remaining RAM, or else otherwise it will throw out of memory error. Okay, out of memory error. See, suppose you have mentioned work underscore mem as a 1 GB. You have a 200 connections. 200 into 1 GB means 200 connections utilized at the time. 200 into 1 GB means 200 GB, right? 200 GB, you will get out of memory error. All the queries will be failed, right? You have only 12 GB remaining, but here it is occupying, it is looking for 200 GB. So it will get the out of memory error. Always see work underscore mem value should be very less, either 4 MB or 18 MB or 16 MB. If you think specific query need a work underscore mem, more work mem, complete request faster, at the time you can increase for the only session. I'll tell you only session level how to increase the work underscore mem. I'll tell you. Okay, if you change the parameter in PostgreSQL.conf file, this is common for all sessions. Need to restart PostgreSQL services. We can give session level as well, only for that session. We can assign user level as well, only for that user. What are the queries running from that user? All the queries to that work underscore mem will be applied. Okay, we can assign DB level as well. Work underscore mem you can assign a DB level, user level, session level. Okay.
We do not have PGA, right?
Sorry.
In Oracle.
Sorry.
We do not have any common memory like PGA in Oracle.
Yes, that one actually in Oracle we have SGA and PGA, right? System global area, process global area. This work underscore mem is a PGA, process based.
But that is global for all the process. This is like specific to process, each process.
Yes,
right?
yes, that is the one. That is actually that whole PGA will be shared, right?
Right.
But here not like that. It's a process based. For each process, that set of value will be assigned.
Right. So if my application, right, one application, not one session. So if it needs more memory intensive, like ordering and sorting, is there any way to?
Correct. See, one application means definitely you will use one user, right? One application, one user. One application, one user only you will use, right? For database connection. So in that case, we can assign user level, right?
Okay. So I mean, okay. So only it will be set at user, session, or DB level.
Yes, your wish. On ad hoc basis, we will set it at a session level. Ad hoc basis. This is your point. If you want to set it for application level, for that application user, we will set it a bigger value. Bigger value means some certain limit. either 16 MB or 32 MB is the more value. 32 MB, very big value.
So in general, is this a common issue in production scenarios?
No. Normally 4 MB is enough. 4 MB is enough. In worst case, sometimes we will increase to 32 MB for either user level or session level. Worst case. If they are seeing huge slowness, or else if they want to complete the query very faster, in that case only we will do it ad hoc basis. No restart required, nothing.
Okay.
On ad hoc basis thing. If you want to change in PostgreSQL.conf, for that you have to restart. For session level, user level, you no need to restart. Okay.
Yeah, and one more thing. So in my software, 2 or 3 databases are running. I want to change one database work memory order. After changing that, I need to restart all the databases or only single database?
See. In DB level, you no need to restart. See, if you want to if you want to apply for all the databases, then you have to change in PostgreSQL.conf file. Only one database means you can set it a database level.
After setting, I need to restart is not required.
Not required. One database not required. If you want to apply for all databases, you have to change in PostgreSQL.conf file, you have to restart.
Okay. It will affect all the databases.
Correct. I'll show you this thing also. I'll show you. Okay. Once installation done, everything step by step I'll explain you.
And Babu, in this PostgreSQL server, we don't have a dynamic P file.
Actually, there is no concept of it is just like a SP file. There is no dynamic file. It is a static. PostgreSQL.conf is a static file, but it is just like a SP file, not a dynamic one. It is similar, just similar. Okay. So it is in text format. Actually, in Oracle, P file is there, right? P file not in editable format. We need to convert it as a SP file, right?
So that in Oracle, SP file is also there.
Yes.
Many parameters we can set on the runtime.
Yeah, here not like that. Here directly you can edit the configuration file. Okay. So see, next temp_buffers. We will create temp tables. We will use nested joins, right? So while creating temporary tables or working with nested joins, this memory will be for temp results. This memory will be useful. Okay, will be useful. This is also local. Will uses from remaining memory. 64 MB is the default value. And enough value. Okay. Don't need to bother about this. Temp_buffers. Normally, see why for nested joins it is using means select star from EMP where employee number in. Select employee number from department where department number in. We call this as a nested join. Join inside join, we call it as a nested joins. It is generating more temporary results, right? See, first this query should execute. It will generate the output. That output should be stored somewhere. Then this query will be execute and it will call this query result set. Then it will get a result set. It will keep in some area. Then it will execute. Okay. Then it will call this complete result set. So more number of temporary result sets are generating. That is the reason during nested joins temp_buffers will be used. Anyway, while creating temporary tables, definitely temp buffers is mandatory. In the above case, most of the times temp result sets will be generated, right? So we need a temp buffers to handle these temp result sets. Always parent query will be depends upon the child query result set, right? See, we will call this as a parent query. In braces, we have a child query. So first child query should execute. Always parent query will be depends upon the child query result set. There is a very minimal difference between parent and a child query execution. Okay. So in that gap, to maintain intermittent results, this will be take care. Okay. So next one, this is 64 MB. Default value is 64 MB. 64 MB is enough. You no need to change. Maintenance work mem. This is also local memory area. Okay. For any database, maintenance activity is mandatory, right? Any database maintenance activity mandatory. Keep the database safe and faster. Most of the times these will be done manually. But for any database, maintenance activity is mandatory to keep the database safe and faster. Most of the times this will be done by manually. But in PostgreSQL by default we have some utilities. We have some utilities to perform maintenance activities. Normally, any database people will perform maintenance activity manually, right? But in PostgreSQL, we have an option to run it manually. At the same time, we have an option to run it automatically. Automate the maintenance activities. While running those utilities, this memory will be consumed. See, during maintenance activity, during manual maintenance activity, we may increase this value at session level to speed up the maintenance activities. Okay, maintenance activities. I will tell you what are the maintenance activities later. Okay. See, one more process is there. Auto vacuum maintenance work mem. See, auto vacuum maintenance work mem. Here, sometimes we no need to run maintenance activity manually. PostgreSQL will take care automatically. If you are okay, PostgreSQL will take care automatically. The type of maintenance activities we call it as a auto maintenance activities. In that case, this memory will be used. Okay, utilized to speed up. Okay, now effective cache size. This one actually auto maintenance work when these all are almost 1 GB to 2 GB is fine. Fine. If maintenance activities are running, it will occupy. Once done, it will release. Okay, this is the memory. No impact. No impact server due to auto vacuum. See, effective cache. This is a dummy value. Boost up PostgreSQL operations and to show how much memory, how much free memory we have for PostgreSQL operations. Okay, just like it is for showing. If you are doing one activity, if they are saying we have huge free space, then you will get an encouragement, right? You will get a boost up. You will do it very faster. Okay, I have enough memory. I can complete this request very faster. You people will think like that, right? The same manner, PostgreSQL also just playing a trick. It is showing like enough memory, enough free memory to optimizer. Then optimizer is trying to generate a best cost execution plan. Normally, if you assign very big value also, there will be no impact to the server. It will be not utilize the RAM. Okay, just for show only. We can assign 85% of RAM as this value. If your system RAM is 16 GB, you can assign 14 GB as an effective cache. It will be just for namesake only. No resource consumption, nothing. Okay, there might be a very less chances to increase the performance. There will be no performance drawback. Mandate 100% is sure. 100% is sure. There will be no performance drawback. Sometimes there might be a chances for performance improvement. Okay, to this effective cache, these all parameters we will define in PostgreSQL.conf file only. See, default 128 MB. If you want to assign, see, Above all parameters, you can set it in a PostgreSQL.conf file. All are memory related parameters. So PostgreSQL restart services restart is mandatory. Okay, mandatory. For your information, for if any parameter requires restart, that will be clearly mentioned in PostgreSQL.conf file beside the parameter. Okay, beside the parameter they have mentioned very clear. This parameter requires restart. They mentioned like that. Okay. So, anyone have any doubts on this memory-based architecture?
Yeah, Ram Garu. So on the effective cache size, right? Is it like target underscore mem, something like that, or what is it basically going to increase? Shared buffer?
See, actually, it's no. While generating execution plan, optimizer looks for resources. Okay, resource. At that time, effective cache parameter will be appeared value of first appeared value. Will be the first appeared value. That means optimizer will think we have this much free space for processing request. So it will get boost up and try to generate very effective execution plan. See, let's suppose you are looking for you are preparing for one competitive exam. One notification came. First you will see how many number of vacancies, right? If you have 1,000+ vacancies, then you will get more confidence and you will try very hardly. Let's suppose in the notification they have given 10 posts. Definitely you will disappoint, right? Not only you, most of the people will disappoint. People who are preparing seriously, they will not disappoint. There will be no change in their expression. Either less number of posts or high number of posts, their preparation will be same manner only. But some students are there, right? They will prepare based on the opportunity, more opportunity. If huge number of openings are there, they will try to work hard. If very less number of openings are there, they don't want to try hard. In the same manner, first optimizer will try to generate the execution plan. It will see the effective cache value. Effective cache value means just like a free RAM for processing. It will see, okay, 85% of the RAM is free, so I can perform my query very faster. It will try to generate a best execution plan. That is the reason it is just a dummy value. It is just to cheat a optimizer. Okay, most of the times it will not work. See, one candidate preparing for the exam seriously means he will not bother about number of posts, right? Even one post also, his preparation will be like that only. So query which is having exact statistics, there will be no change in the performance. Query which is not having proper statistics, there might be a chances of performance improvement. For that, effective cache will play key role. That means if you are mentioning 85% means that is not utilizing, that is for just for show only.
So we can set to entire RAM value whatever we have at the host.
85%, not 100%. It will not take. Okay. It will not take. You can set 85%.
Okay. Thank you.
And one more thing. Be careful. Read careful. See, when to increase when, which value? When work underscore mem need to increase, when temp buffers need to increase, when auto vacuum, when maintenance work mem need to increase. These values you should be very clear. Okay. If you are very clear about this area, then you are a good DBA. So this is the memory based. Next one is process based architecture. See, by default, if you start a PostgreSQL services, we will start only postmaster process, right? In any database, we will start only services, right? That is, services will be only one process. But in backend, you will start some set of processes. First one is, see, even though you are starting only one process, it will start the backend some set of process. Oracle also same thing, right? It will start some backend process. BG writer, something is there, right?
Yeah, the check pointer, log writer.
Same thing.
S1.
Same thing we have in this PostgreSQL. Normally, you start the postmaster process. That's it. Starting and stopping services. But by default, it will start some backend process. First one is writer process. Second one is wall writer process. Checkpointer process. BG writer process. Archiver process. Stats collector process. Auto vacuum launcher process. Wall sender process. Wall sender process, okay? Wall receiver process. See, almost we have 9 processes, right? In the above processes, optional processes are there. See, archiver process, auto vacuum launcher process, wall sender process, archiver process, wall receiver process. These 4 are the optional. If you want to enable, you can enable it. If you want to leave it, you can leave it, okay? But see, first 4, writer, wall writer, checkpointer, BG writer, this, and one more thing, stats collector. These 5 processes are mandatory process. Remaining 5 mandatory process. You cannot kill. You cannot kill those processes, okay? If you want to kill, you can kill optional processes. No impact to server, okay? Don't touch mandatory process. Right? So, see, first writer process. In PostgreSQL, each and every transaction will be recorded at operating system level, okay? Each and every transaction, whether select, insert, delete, whatever it is, each and every transaction will be recorded at operating system level. Those entries will be recorded by one process. See, normally you have an organization, okay? You have an organization. In that organization, you want to record each and every activity happening. To record that entries, one clerk will be there, right? In the same manner, in operating system, whatever the transactions happening, each and every transaction will be recorded at operating system level. Those entries will be recorded by the one process. I told you already, in operating system, if one work is doing by one worker means we call that worker as a process. So here, all the transactions will be recorded by one process. We call that process as a writer process. Okay, all these transactions will be recorded into one file. We call that file as a wall file, write ahead log file. See, complete PostgreSQL will be depends upon this file only, wall files only. Okay, just like read log files in Oracle.
Just like in Oracle, we have only read log file for the
Correct. See, each and every transaction will be recorded into one file. That file we call it as a write ahead log file. Default size of this file size is 16 MB. Okay, 16 MB. For each 16 MB transaction, one new wall file. 16 MB transactions, one new wall file will be created. These files will be located, see, under pg_xlog directory, under data directory. We have a data directory. Under the data directory, we have a pg_xlog directory. Okay, under the pg_xlog directory, wall files will be created. Up to 9.6, there is a directory called pg_xlog. From 10 onwards, there is a directory called pg_wall. They renamed it, okay? Under data directory only, pg_wall directory is there. Default size of this xlog directory is 1 GB. Xlog, see, pg xlog or pg wall, whatever it is, default size is 1 GB. That means capacity of that directory is 1 GB. At a time, 64 wall files can save under the pg_xlog directory, correct, right? See, one file size is 16 MB. Capacity is 1 GB means at a time we can store 64 files only. If 65th file comes means first file will be removed from pg_xlog directory. Even though wall files removed, there will be no impact on service, okay? No impact to services. See, you got my point, huh? Writer process will record each and every transaction into wall file. That wall file size is 16 MB. Sorry?
So you are saying, so Babu, like pg_xlog is location for this
Wall file.
wall of file.
Up to 9.6. Up to 9.6. 10 onwards, it is renamed as a pg_wall. Under
And
data
every
directory.
file size is 16 MB, and normally this is a normal case in every environment. Like we will always see 64 files.
Yeah, always 64 files. See, if you want to increase pg_xlog size, xlog directory size, okay, you can increase by changing max_wall_keep max wall keep segments, okay, parameter in PostgreSQL.conf file. Oh, nonsense. Every time it's coming. I need to uninstall this one first. Parameter in PostgreSQL.conf file, okay? Conf file. At the same time, if you want to increase the wall file size from 16 MB to 1 GB or something like that, okay? You can increase while database initialization, okay? Initialization, I will tell you what is database initialization, okay? See, if wall files cleared from pg_xlog directory, there will be no impact to services, but suddenly if you want to perform point in time recovery, okay, these files are mandatory. So best practice is maintain a backup copy for all files, just like archive files in Oracle, okay? I'll tell you. So next process is wall writer process. Writer process will
Babu, like out of 64 files, if we delete 10 files, then there is no impact.
automatically it will delete. See, we should not remove wall files manually, okay? Manually, automatically it will be clears, okay? Clears. If that limit reaches, if the max wall keep segment limit reaches, automatically wall files will be cleared, okay? Cleared based on your disk space availability. You can decide, you can define this value, okay? If you have enough space, you can maintain 1000 wall files, 2000 wall files. If you don't have enough space, you can maintain like 100 wall files, like that. That is up to you.
Is there any background process will be delete this file?
Yeah, any background process for
any background process will be clear this wall files after reaching the max size?
This is auto clear actually. Auto clear. There is a process called wall writer. Wall writer process is there. Yes. See. Wall writer process. Writer process.
But Babu, if we manually delete, then there is no impact, right?
No. You should not delete manually. Delete manually. You have to follow one strategy. I will tell you that strategy. Okay. Never delete never delete blindly. We have to follow strategy. Okay. One strategy is there. It's a good question. Actually, we will never touch pgxlr. Until unless if you get that situation, you have to follow one strategy. I'll show you that strategy. Okay. See, writer process will write all the transactions into wall file, but those transactions will be in shared buffer area. See, writer process will write all the transactions into wall file, right? Those transactions will be in shared buffer area. That means not committed. That means not committed. Not committed. Okay. It means not committed. But wall writer process will apply changes permanently to disk. So we call the wall files as a committed transactions. Wall file means all the committed transactions. Earlier, writer process will write all the transactions into wall file, but we will not call it as a wall file. Those transactions will be in a shared buffer area. Shared buffer area means not a committed transactions. Once see, wall writer process will apply changes permanently to disk means those transactions are committed, successfully committed. By default, PostgreSQL auto commit. See, I'll tell you one thing. This will auto commit option will be happen. There are two processes are there. One is checkpointer process. Another one is BG writer process. Here, see, second, yes. See, end user shared. I have the graph. Okay, shared buffer area, wall buffer area. Two areas are there. Shared buffer area, wall buffer area they are there. Then for shared buffer area pointing to BG writer, wall buffer area pointing to checkpointer process. Okay. Underlayer disk will be there. Any user want to perform any query, first optimizer will get the data from disk to shared buffer area and it will performs respective operation, right? Respective operations. So data will be located in shared buffer area. Respective transaction information will be located in wall buffer area. So if transaction committed, checkpointer process will applies transactions. Checkpointer process will commits transactions into wall file. Once checkpoint applied on transactions, BG writer process will flushes respective data into disk from shared buffer area. You got my point, huh? Hello. Yogesh?
It's clear, but suppose application holds up the process and they are not committing.
No, didn't get you.
I'm saying they are not committing the records. And they have put hold their operation. Means all the transactions are getting filled in the wall log file, and that area need the space for other process. Then what will happen?
No. Here one thing you have to remember: PostgreSQL is a default auto commit. PostgreSQL architecture is default auto commit until unless you are performing operation in BTET mode between begin and end transaction, okay? And transaction mode. So whatever the transaction you are doing, automatically it will be committed to wall file. Check pointer process will continuously running plus the committed transactions into wall file.
So you are saying that wall file will always have committed transactions.
Correct. Auto commit.
There is no chance of getting uncommitted transactions in the log file, wall log file.
See, if you are doing between begin and transaction means there will be no entry. Correct. If you are doing in BTET mode, transaction not committed means the transaction will be resides in shared buffer area until commit. If you not commit this transactions, that transaction will lose. Okay. See, if just like rollback from shared buffer area, wall buffer area, from wall buffer area, not from wall file. See, if it is not committed transaction means that the transaction will not appear in wall file. That transaction will be appeared on wall buffer area only. If transaction failed in middle, it will be rollback from wall buffer. Here two things. One is you have to remember two things here. One is data, one is transaction, right? Based on the transaction, data will be changed. Data will be registered in shared buffers. Transactions, list of transactions will be appears on wall buffer area. See, check pointer flushes committed transactions to wall file. Here, BG writer flushes change data to disk. Okay, this is the way.
So when the transaction will roll back, user will get notified.
Rollback means, see, if you are one second, if you are performing BTET mode, if failed, user will get notification. At the same time, if you are using synchronous replication, if transaction fails, user will get notification. If transaction fails due to server shutdown, or server crash, user will get notification like connection terminated. Okay, not like not saying like transaction not completed successfully. That type of message you will not get. You will get a notification like connection got terminated. But in this case, you will get exact notification. Transaction not committed. Please rerun the query. Something like that. Okay. This one also. This both will give you exact notification. I will show you during the synchronous replication. I will show you. Okay. How the exact notification is getting to user.
It has to be in a VCAT mode, right? So there is no way we retain the transaction for a long period of time.
There is no way. Only for beta and this one only.
Okay.
If you want to use checkpoint also, we will use, right? Normally checkpoint, auto save point, something like that. Save point is there. Up to certain level, save point applied. That one also there. Save point concept. I'll try to cover that one. So this is the way. And one more thing, where I left somewhere. Yes. Where it is. So you have this one, right? Wall writer and checkpoint and busy writer process, information, detailed information. Now, archiver process. Normally, there will be no impact, right? No impact if you are clearing the wall files.
So the transaction is auto committed, right? So I want to roll back after. So can we roll back the transaction?
Oh no, that's what I told you, right? Rollback will be possible in BTET mode. Okay, begin and end transaction. Any set of transactions, in middle of begin and end transaction. Okay, then only it's possible.
Which is like any parameter like.
Yes, begin and end. While before running the query, I'll show you. Before running the query, you have to enter begin, then you have to run the set of queries, then you have to enter end like this. Begin.
What is that BTET mode?
Begin and end transaction. See, suppose insert into, this is registered in all databases, right? Inserted into EMP values. Let's assume 1. Insert into EPT values. And here your intention is if successfully completed means two statements should be complete, otherwise both will be rolled back. What is your intention? See, once employee value 1 inserted, while executing the second statement, it's failed. That means then they don't want to insert data into EMP as well. Then it will be rolled back to this one as well. Even one failure also automatically roll back from all the statements until unless even one statement fails, all the statements will be rolled back until unless you are mentioning commit in middle. See, if you are mentioning like every statement, if you are mentioning commit, okay, this, or else it will be rolled back automatically. If one statement fail also, automatically roll back until unless you are mentioning the commit manually.
So, Ram Garu, like in general, if we are executing anything in production from the developer scripts, right? Normally, first practice is to set auto commit to off and then execute, or developers.
No, there is no way of auto commit to set off. Normally, this one will be if your statements, set of statements are dependent one by one. One statement is dependent upon another one is dependent upon another one. In that case, what they will do, they will create a stored procedure. In the stored procedure, they will use this begin and end transaction. In middle, they will write a 10 transaction, 10 statements.
Right. This is about transactions, but I'm just asking in general. So
you cannot put auto save mode off, auto commit off. You cannot.
There is a parameter, right? They set auto commit off.
In Oracle, it's there. PostgreSQL, I don't think.
It is there, sir.
Okay. I'll check them. I never use that one. Default mode we are using. We'll see. I'll check that one if it is there. Auto save.
Yeah, because if the row count doesn't match, right? In Oracle, the developer want to update
No. Oracle, I'm aware. Oracle, it's there. You know.
So in Postgres also the same situation occur, right? Like
that's what. In PostgreSQL, I'm not sure whether that parameter is there or not. I'm not sure. I will check that one.
Yeah. Okay.
Auto commit, right? Auto commit off option. I'll check that one. I'll check that one. Huh? Okay.
Yeah. Thank you.
Next one, archive process. See, normally take wall files backup parallelly. Need to enable archive mode. In Oracle also we will enable, right? Archive mode, something like that. So an archive process will start taking backup of wall files. Next one. These wall files will be these.
What is the directory?
Sorry?
What is the directory for this archive process? Backup block?
So, didn't get you. Yogesh, you're saying something?
Yeah, what is the directory for this archive?
Correct. These archive files will be located under specific directory which you have provided in PostgreSQL.conf file. Okay, PostgreSQL.conf file. In PostgreSQL.conf file, we have below parameters. First one, archive underscore mode should be on. Archive underscore command is equal to CP. You have to copy. Okay, CP. You have to copy wall files. %p. You have to give the path. Suppose valid your wish. Is equal archive. You have to create this directory. Wall file should be saved with the same name. What are the name you have in underscore xlog directory with the same name? So that is the main reason. %f. %f means file name which you have in pg underscore xlog directory. Okay, directory. %p means path to copy wall files. Okay, is enough. cp is the normal command. If you want to keep archive files in a remote server, use below command. Archive underscore command is equal to scp -p or else scp, something like that. %p enterprise db username, enterprise db @192.168.13.12. okay, colon where label is equal archive. Okay, %f like this. Okay.
Can we copy to multiple locations at same time?
Same time, yes, you can copy. You can copy. We have one more parameter called end. Okay.
Okay.
Ampersand, and you can give the path. Okay.
Oh.
Another path.
What is the default location in Windows?
Nothing. Default location, nothing will be there. You have to provide. Archive command.
Okay.
See, default is empty. You will not record anywhere. Both archive mode is off, archive command is empty. So If you want to enable archive mode, definitely you have to give the archive command. The path you have to give. So directly, your wish. Either C folder or D folder, what is it? See, on top of archive folder, Postgres user should have permission, okay? Should have write permission. That is mandatory. Next one, charts collector process. Database, statistics should be up to date, right? Then only our optimizer will generate the best execution plan. Always statistics should be up to date. Then only best execution plan will be generated. Charts collector process will keep statistics up to date. Next one, auto vacuum launcher. I told you already. If you don't want to perform maintenance activities manually, you can automate. Then this process will take care. Wall sender process and wall receiver process. As part of replication, our data will be copied from one server to another server.
What kind of maintenance activities?
Sorry?
What kind of maintenance?
Yes, I'll tell you that we have a major concept. Maintenance activities, we have major concept. Okay. Fragmentation, defragmentation, and data redistribution, re-indexing. These all are actually PostgreSQL given a predefined maintenance activities. We'll see that topic later. Huh?
Okay.
Yeah. See, as part of replication means copying data from one server to another server, right? So one server is the master, another server we call it as a slave server. Or else one server we call it as a primary, another server we call it as a secondary. So as part of replication, data will be copied from master to slave. See, data will be copied in the format of WAL files. From master, WAL process will send the WAL file, and slave server, WAL receiver process will receive the WAL file. See, and the master. Let's suppose Naveen is the slave. Always Naveen wants to be sync with me. So whatever the changes happening to me, that same changes should be happening to Naveen. Here, that changes will be happen in the format of WAL files. So let's suppose some set of transactions happened on top of me. So I have a WAL file. That WAL file I need to transfer to Naveen. As a PostgreSQL server process, I will not transfer. So for transferring WAL files from one server to another server, there is a process called WAL sender process. WAL sender process will transfer the WAL file from Rambabu to Naveen. Naveen is the slave machine, right? From Naveen side, Naveen will not receive the WAL file. There is another process called WAL receiver process. That WAL receiver process will receive the WAL file from Rambabu. So these two will play key role in a replication part. Okay, that is the reason this one auto vacuum launcher. If you wish to enable automatic, you can enable. If you want to enable replication, you need to enable these two. That is the reason I told 4 optional process. Archive process is optional, WAL sender optional, WAL receiver optional, auto vacuum launcher optional. These 4 are optional. For which you cannot touch that BG writer, checkpointer, WAL writer process. You cannot touch that. Okay. This is about process-based architecture. This is about complete PostgreSQL architecture, general architecture, memory-based architecture, process-based architecture. These 3 will play key role in the PostgreSQL complete behavior and performance. Okay. Anyone have any doubts on this top of architecture? Hello? Anyone is there? Disconnected. Naveen?
In generally, in interviews, how they will ask about
Sorry?
architecture.
Yeah. In interview they will like this. Tell me about the architecture. Blindly you can go. PostgreSQL is a purely operating system based architecture. This architecture will be divided into 3 parts: general architecture, memory based architecture, process based architecture. Coming to general architecture, this is common for all the databases. First thing is it will start from query execution to until get the result set. There will be some generic steps. On top of generic steps, we have syntaxer, resolver, security check, optimizer, dispatcher is there. Once done with that, if we move to memory based architecture, we have these type of memory based parameters. Then you can explain shared buffers, work underscore mem, temp buffers, maintenance work mem, effective cache. After completion of that, you can go to process based architecture. I think while explaining the architecture, once you get into memory based architecture, he will stop you. This complete process to explain, almost it will take 20 minutes. You. Okay. So, any questions before proceeding with installation?
Yeah, one question. Maybe it's already too advanced, but like we have in ADDM reports, right? Like the memory congestion.
ADR, right?
Yeah, ADDM and AWR. Like in Varaki, so do we have similar report where it says like, okay, your shared buffers are less or something like that?
We have, but not like a hint. It will not give any hint. For that only I told you, right? I'll give you one link. This we call it as a PG tune. At this moment I will not tell. After some time I'll tell you. Okay, how to define the parameters level. Okay.
Right.
But if I forget also, you people just remember me. How to define.
But that is static values, right? That is like based on the preset value. Yeah. So is there any way based on how our system is running, how our developers
correct. How to define parameters according to our environment.
Oh, okay.
Environment, okay. I'll give you this link. Maybe tomorrow I'll give you. Once all paid fee. I think 4 members paid. I think remaining need to pay today.
Yep.
Yeah. Okay. I'll tell you that. Don't worry. Tomorrow I'll give you that. Once all paid fee, I'll send this video and notes and everything. Okay.
Babu, Yogesh, I will pay after this class.
Sorry.
I will pay today. I will pay after this class.
No problem. If anything is there, just ping in group. No problem.
Okay. How do you know that which is the dynamic parameter, which is the static parameter? Like
again, you are coming to starting point. I told you, right? See, for anything, I told you first. Beside every parameter, there will be a comment like this change requires restart. I told you, right? See.
Okay.
That is the.
No. Just I understand. So after opening that Postgres.config file, we will get to know that based on the comment.
Correct.
So after opening the database, I want to know that this parameter.
No. Opening PostgreSQL.conf file is just a fingertip. That one. Just you can play that. See. As a developer, you will never access this one. PostgreSQL.conf file. As a developer, as a DBA, that complete server is in your hands. You can easily go to the PostgreSQL.conf file or else to know all the parameters. See, to know all the parameters, we have a query. Just like in Oracle $vs are there, right? Have a query. I will give you that query. There is no direct query to get the static and dynamic values. Like Oracle we can able to know that. But only one option is based on PostgreSQL.conf file entries only. Okay. These are the one drawback only actually. To say frankly, this is drawback only. In Oracle, easily you can come to know that. Even developer also can come to know that, right? What are the static values? What are the dynamic values?
No, he will not.
No, after logging into the database, he can run, right?
No, he cannot.
He cannot. Yeah. Once logging into the SQL Plus, he can able to write. He can able to run the $view, right? To display all the.
Yeah, he can write, but apart from the SQL place, he will not get any system information from.
Maybe that guy should have proper access. That user has proper access means he can able to do, right? Yeah. Okay, we'll do one thing. Take a 10 minutes break, then I will complete installation today. If anyone getting bored means we will continue installation tomorrow. Roish.
Yeah, better we will do tomorrow.
Tomorrow, sorry?
Better we will start installation tomorrow.
Okay. Yeah, my intention is we will cover today. Okay. Tomorrow 6 o'clock we will meet then.
Okay.
Yes, yes.
Okay, thank you. Bye. Please send fee today. I'll try to send fees today.
Yes, yes.
Yeah.
Okay, thank you. Thank you so much. Bye.
Tomorrow is 6:30.
6 o'clock. 6 o'clock only.
6 o'clock to
6 to 7:30 or 7. 7:30 at least.
my shift timing will be changed.
6 to 7. Yeah. Okay. Bye.
6 to 7.
Okay. Okay.